Hi, everyone. I'm Gary Scher, and today we're going to talk about building a coordinated response to a DDoS event with AWS. So, to start with, tell you a little bit about me. I am a solutions architect at AWS. I've been at AWS for a little over 3 years. Before that, worked at a content delivery network provider, doing very similar things, working with um, supporting the topics that we're going to talk about today, which is edge services and edge security, and the whole DDoS protections scenario. And then before that, I spent multiple years, a bunch of years at a telecom where I was doing. I started off in system administration, then I did some security roles in IT security, and then moved on to web development. So it boils down to I have got a background in web security and IT security, and multiple years, 6+ years, focused on the edge security, which is what we're talking about today here, which is protecting web applications and IT, IT infrastructure from the internet, which is the edge is where servers are close to users. So the security to protect web applications from the edge users, from the potential attacks at the edge is where I've spent the last 6 years. So let's jump into today's topic. So I've got a agenda here, and so I'm going to start off. First, I'm going to define I've already used the term DDoS. I'm going to define what that is first. I don't have that on the agenda, but I'm going to define what that means first, and then we're going to get into an example scenarios. So think of these as customer stories, where we've pulled together some situations that we see repeatedly, and they are going to be very generalized, not a specific customer, but they're patterns that we see with a bunch of customers. I personally have interacted with customers in all three of the scenarios that I'm going to talk about. Multiple customers in each category. So what I would recommend when you are hearing the scenarios, if you don't fit directly into one, you most likely you have a lot of overlap with one and possibly two or three of the scenarios. So just I think all the scenarios will be useful as a way to tie together the topics that we're going to cover today. And then I'm going to go a little bit more into what DDoS is. So I'm going to define it at first, but then we're going to go a little bit deeper into explaining, what it is, and what customers experience with when a DDoS event happens. And then the next question, and I hear this question from a lot of customers that are, is this an architectural problem? Can I solve this problem if I design my application better? And so we'll answer that question, and then we'll talk about the main thrust of today's conversation, which is how should I respond to a DDoS event, a DDoS attack? What should I do to when it happens, and what should I do after it happens? And then the last topic will be a thread through all of this, which is how can AWS help? Can AWS solve this problem? Can AWS help me solve this problem? And if so, how? So we will go through that, and basically throughout the conversation, we will have references to how AWS can help. So what is DDoS? The acronym stands for Distributed Denial of Service. So what that means is some group of sources are attacking or attempting to attack a service or an application. And in our usage of the term, distributed means more than a handful. So 10 plus, 100 plus, potentially tens of thousands. But it does not mean, five, people with a laptop are going at one website. That's not really distributed. And so the situation that we're talking about with DDoS doesn't as much apply when you've got a scale that's that small. When we're talking about DDoS, we're talking about larger scale events. And then on the page here, you see some, an example of what it looks like potentially when an actual web service or web application is hit by denial of service attack, where the page simply won't respond. And it's because it could be we'll get into all the things that can cause that, but the short of it is the page is not responding. And when you see on the above that in red are the HTTP status responses that you will commonly see in your browser. If you were to look at your browser, what your browser is seeing, it's 500 series errors, which in the RFC means that they are server side. So the client, the browser knows that the problem is not on their end; it's on the far end. And so we're going to basically walk through how to deal with and prevent those 500 errors from happening by using tools to mitigate the DDoS attack. And then of course on the right is the what a web page looks like when it does not under attack. So there's no 500 errors. There's the page fully loads, and everything looks normal. So on the left is a DDoS attack. On the right is not a DDoS attack, and so we're going to walk through how to deal with a DDoS attack, and we'll expand upon the nature of what makes up a DDoS event. All right. So for common scenarios, I pulled together 3 examples. The first one is kind of an obvious one, which is I am not using DDoS protection of any sort. I do have scalable infrastructure maybe, but that's it. I don't. So I can deal with the attack if its scale is small enough that the infrastructure I have will cover it. We're not going to focus on that as much, but we are going to cover the question of, could scalable infrastructure solve the problem? So that'll probably be one of the next things that we bring up. But as far as the other customer stories, the common pattern is you have DDoS protection, but you just clicked the button and called it a day. You didn't do the full implementation to set it up in the proper recommended way. So we're going to get into what that looks like and how that impacts you. And the short answer is the effect is very similar to the you have no DDoS protection, because the effect is basically the DDoS protection is not effective at all. So we'll get into the steps to so that it is effective. And the last one is you did properly set up DDoS protection, but you're now seeing an impact where you didn't expect to see an impact because you thought I've got this set up properly. How am I getting impacted still? And so we're going to talk about number one, what you do in that situation, and then number two, now that you've mitigated the initial attack, what do you do going forward, or how can you prevent this from being a problem going forward? So the first scenario is pretty obvious that apply DDoS protection, and that's how you resolve the lack of DDoS protection. The second and third is where we're going to focus most of our talk today on. So we're going to talk about how do you make sure that it's configured correctly, and then on the third one, how to deal with it if there is a situation that you thought should have been stopped but was not stopped. Okay, so what does a DDoS event look like? Or what is a DDoS? How should we respond to a DDoS event? So as the slide mentions, the answer is it depends. It depends on the nature of your infrastructure as well as the nature of the attack. And we're going to get into how you distinguish the nature of the attack as we go through here. But the thing on the slides are there's 2 possible areas that need to be protected. One is a data center, which not on AWS, and then the other is where you're running in the cloud and you're running behind in AWS, and in there we can still protect stuff that's running in your own data center. So I don't want to give the impression that the answer that I'm driving towards is you must have everything on AWS. That's not the case, but we are going to spend a little more time talking about AWS because a lot of the DDoS protection we're talking about works more effectively if it's on AWS. So it's not that you have to be on AWS. It's just that you will have more options and better options if you are on AWS for dealing with these sorts of DDoS events. So as you see on the screen, it's got EC2 instances as for the AWS portion of the example infrastructure. And then as I expand down through it, the next thing that they show in the architectural diagram is a auto scaling group, and we'll get into why that's important in just a second. But that is a part of protecting against DDoS is being able to scale. And then there's an elastic load balancer in front, and that kind of closely couples with the fact that you're going to be able to scale. In order to scale, you have to have something that will send the traffic to the scaled portions. And in the AWS world, that's typically an ALB, but it could be an NLB. So it could be an application load balancer or a network load balancer. But some kind of load balancer has to be in front to be able to distribute the traffic to the compute instances that have been scaled up. And it says EC2 instances here in the example, but as we'll see in some of the later slides, it doesn't have to be EC2. It can be just whatever compute layer you're using. And then after you've got your elastic load balancer and your compute instances scaling, you then need some additional pieces to be truly resilient. And we're going to go through all of this in a little bit more depth. But what you see there is the Route 53, which is AWS's DNS solution, and then CloudFront, which is AWS's content delivery network, and then Global Accelerator, which we're not going to spend as much time talking about, but it's for things like TCP and UDP traffic. So the point basically is if your traffic is not HTTP based or HTTPS based, there are AWS solutions that can help you, and Global Accelerator is an example. And then Shield is where we're gonna whenever we start talking about the DDoS solution for AWS, it's going to be attached to Shield. It's not going to be Shield alone, but Shield is going to be kind of at the center of the tools that AWS offers to deal with a DDoS event. And then WAF is going to go right along Shield, right along with Shield. So whenever we talk about mitigating an attack, there's going to be a portion that's talking about Shield and a portion that's talking about WAF. If we're talking about HTTP based services or HTTP based applications, and then we're going to talk a little bit about things like how you get metrics and logs, and CloudWatch is one of the ways you get metrics. And then AWS support will definitely be talked about too, and we'll get into a little more in depth how support factors in. But the short of it is the response to if you don't have protection at all and you need to implement protection, you're going to use the pieces that we show on the screen. And the only part that waffles a little is whether if it's web based, you'll deal with CloudFront. If it's not web based, so it's dealing with TCP UDP, then you might be dealing with Global Accelerator. And like I said before, if you're dealing with a data center, you'll deal with a lot of the same pieces if you're relying on AWS for DDoS mitigation, but you won't deal with all the same pieces. So, for example, CloudWatch may not be a factor at your application layer, but it would still be a factor at your if you're using CloudFront in front of your data center. Then there still be metrics within CloudWatch that are related to CloudFront, but not related to the application itself. All right, so what do you need to be resilient? So this is basically trying to get you a sense for the fact that tools are not the only part of this. You need people. So you need your response team to deal with when you experience an attack or a DDoS event. You need a team that understands how to use the tools and how to work with the rest of the teams within your support group. And then you need, if you're dealing with AWS, you're going to want to work with the AWS support team as well as the SRT. And the SRT is the Shield response team. So they are experts at dealing with DDoS. So now, whether you interact with SRT and they pull in support, or you interact with support and they pull in SRT, it doesn't matter immensely the order of events. But what does matter is if you are experiencing a DDoS event on AWS, most likely both of those two teams will be involved to help you. And then another piece of this is architecture. We've already touched on this a little bit about whether or not you have scalable architecture, but architecture is definitely a part to having a DDoS resilient solution. And so auto scaling is one aspect of that. It's not the only aspect, but it's one aspect. And then another part of it is making sure that everything is well documented. In order to have a effective, resilient solution, there has to be documentation that provides a verification of the design. It provides includes the details that your teams that are supporting this, into the future can follow, so that it's not, in one guy's head, or one team's knows how to do it, but nobody else does. Well documented means well documented, and then that information is available to those who need to interact with it. And the last piece, and that's to where we're going to go a lot about today, is tools and instruments. So how are you going to respond? How can AWS help you respond? How can AWS services help you respond? That's where we're going to spend a lot of the conversation today. And when it comes to tools, one of the biggest tools on recognizing a DDoS event and dealing with a DDoS event are logs, whether it be infrastructure logs, like in the case of AWS, that might be CloudTrail or CloudWatch logs, coming from your ELB, or coming from CloudWatch, or coming from WAF. But it's also your application logs. So if you're dealing with EC2 instances, then there may be logs on the servers. Ideally, you have your application logging coming back to a central place, and so whatever that method of storing and aggregating your logs is, you're going to need access to logs to deal with the DDoS event. So that's definitely one tool that you cannot forget. And then application telemetry. So there the application logs don't always tell the full story. The telemetry from the application itself, and that that can be it can be like client side logs if you're dealing with mobile applications. It can be telemetry that's within the application scope, that is outside the scope of what the application logs itself, but is inside the application pipeline. So telemetry is another key source of information. And then the last piece when it comes to tools is or one of the last pieces is playbooks. So when you have people that have to work on the problem, and you have architecture that's designed to prepare, to be prepared for the problem, and then you have tools to help you deal with a DDoS event, you need something to connect those pieces. So your people need to know how to work with the tools, and your architecture team, or the people that are building, that may not have been the ones who designed it, need to know exactly what the expectations are and how to do it. And that's where playbooks come in on all of these. They basically tie the three groups together. And the last thing is alerts and tools to react quickly. So alerts, as is probably obvious, but an alert basically means that an event happened, or even an application is under stress, it's under duress, and it needs to tell you that it's under duress. And so alerts is the a way to do that, is the common way to do that. So when a metric hits a certain threshold, like maybe on an EC2 instance, the CPU load gets so high that the server is overloaded, and not responding, or not able to respond. That's where you can have alerts. They'll tell you, hey, look, we've got servers that are way too highly, they're running too hot, so there's something wrong. And then the scripts in IAC. IAC here stands for infrastructure as code, and what it's referring to is when an event happens, you need to react quickly. Your team needs to react quickly. So if in order to deal with the situation, you need to spin up new hardware, then you need to have the infrastructure as code to spin up the new resources ready to go. So if automation doesn't trigger it, then you have the infrastructure as code, so that it can be triggered with basically something analogous to a button press, and have the infrastructure get spun up very quickly. And then the other thing is scripts. So if you're going to have to make a bunch of API calls, or a bunch of command line activity to deal with an attack, those need to be scripted so that people aren't having to do it on the fly and make it up as they go. So And so that, again, that's just basically to make effective use of your tools. You need to pre-plan what the most likely behaviors that your team is going to need to do, so that they don't have to think of it on the fly, and they don't have to run through a playbook to remember all the commands that they need to run. You can have it in a script, and they just run the script. All right. So you you run into a situation where you need to decide, is this a DDoS attack? Is this a DDoS event? And one of the first things that you want to consider um, is this, what I'm seeing, something else? Is it because caused by a change control, like somebody changed the application, which caused a sudden dramatic increase in the amount of traffic? In that situation, it may not be a DDoS event per se. It may be, the application that caused it. Or another situation is, you're a retail site, and suddenly people start buying your stuff en masse because, a TikToker post, mentioned it in a post or something. Well, that's good that it's a flash crowd, but it's bad if it has the same effect as DDoS. But you still need to know, is what I'm experiencing truly DDoS, or is it something else? And then the next thing is monitoring. We got a long list of stuff here, that like dashboards, error rates, logs, but it boils down to, you need data to figure out what's going on, to know, what the traffic is doing, and what the application is doing, and what the users are doing. And then the last two pieces kind of combine together, which is, what kind of attack is it, and what are they targeting? Um, so is it directly attacking your infrastructure, or is it attacking at the application layer? Or is it a pure network level attack, and the goal is to basically drown out your application by overflowing it with too much data? And then the last piece is 0 day. So is this an attack that's brand new, and never been seen before, or at least never been seen by your team before? That can change how you react, and that is and how you react to that is totally different than how you would react to a network layer attack. And so we'll get into how you do with that here in just a second. All right, so I'm not going to spend a lot of time talking about this, but what you see on the screen are detection metrics. So these are the individual data points that you can use to figure out, is this a DDoS attack? If it is a DDoS attack, what kind of attack is it? What are they targeting? How's my application reacting? Is my application surviving well, and just going maybe a little slower, or is my application just falling over because it's totally overwhelmed? So on the screen, each of the pieces that you would potentially have in your solution, there's different metrics, and they're on the screen. So I'm not going to go through them all because we don't have time, but you can see them, and you can hit pause on the recording. All right. What we're showing here is one example. This, I don't want to suggest that this specific example is like somehow paramount, but it is a very useful example. And what it's showing is, when you have your WAF logs in AWS stored, if you choose to store them in S3, you can use something like Athena to run a query against them. And what the example they're showing here is, in the SQL at the bottom of the page, is trying to get the top IPs that are hitting the WAF, web ACL, that is experiencing a DDoS attack. And so it's just an example, but you see across the screen various data points that you may do something similar to look for, which is, what URI, in other words, what path within my application are they hammering? And obviously, what IP address are they coming from? Because if they're all coming from China, or they're all coming from Russia, you know that might make it easier to distinguish the bad traffic from the good. But it also might be a guide to look at the pattern that's being used from those IPs, and then see if other IPs that are from other regions are also using that same attack pattern. So. All right, so this is the answer to the question I asked earlier on, is a architecture a possible solution to the to DDoS? In other words, can I build the great architecture and solve DDoS without true DDoS protection? And the short, of course, is no. What you're seeing on the screen on the right is a scalable application, but what is included here that yes, is part of the architecture, but includes DDoS protection explicitly, and that's Shield Advanced, which is a little red shield logos on there, and the total DDoS protection has to include the 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 actual tools designed for DDoS, such as Shield Advanced. The infrastructure on the right is great if the scaling, auto scaling is great as long as it actually can keep up. But what most likely happens when you're under a true DDoS event is the scaling, either you have the max scaling too low, or it scales to such a high level that the cost goes through the roof. So relying exclusively on scaling, I've worked with a lot of customers that have tried, and most, if not all, have reached a point where when the event got big enough, they, no matter the scaling, it couldn't keep up. So let me go to the next slide. All right, so I want to real fast talk about the mitigation options. So on the left, you see the layer 3, layer 4 options. We have things like the TCP/IP proxying. So what that means is, if you have at layer 3, there's a thing called a TCP handshake that has SYN-ACK, SYN-ACK. I won't get into the details, but the point is, it starts off with what's called a SYN packet, and without, if you don't have something that's designed to mitigate that, that can overwhelm your resources. So that's just an example of a layer 3 mitigation, is a SYN proxy that prevents a SYN attack from being effective. um, and also it mentions things like filtering, like protocol filtering. So if only certain protocols are relevant to your application, it filters out the protocols that are not relevant. On the layer 7 side, and by layer 7 we mean web traffic, um, the blocking IPs that are malicious, geo limiting. So in the case where I said maybe all our attacks are coming from Russia, you could set up a rule that blocks requests from Russia, and prevent the Russian IPs from getting to you. And we're going to go into a little bit more on things like rate limiting as we go through this. But the point is that there's a variety of mitigation capabilities, and we're going to go through them in just a sec. All right. So here's where we're talking about for layer 7, which is web-based traffic. You see here the recommendations that we commonly see, which is I'm not we don't have time to go through the minutia as to why this is the recommendation, but the short is, you have your allow and block lists, which allow and block individual IPs on the top, and then you have managed rules. AMR stands for Amazon or AWS managed rules. So you have some of our rules that can protect your application level, which is not so much DDoS protection as it is application protection. But then what is DDoS protection is at the very bottom, a base rate limit rule. And the rate limit rule will prevent, it's a very simple thing you can do to prevent a huge volume of requests coming from individual IPs or individual sessions. So we highly recommend that you include that. Now, Shield Advance. I've alluded to what it can do, but I want to real fast drill through it. It can protect your application from a DDoS event, but it can do that through auto mitigation, where it automatically reacts to an attack, and it can also do that through you reaching out to the SRT, what I've already talked about, the Shield response team. So let's talk about Shield, the SRT. You can call the SRT when you can call them when you think there's a problem. So the point here I'm trying to make, you don't have to wait for them to tell you there's a problem. You can tell them there's a problem, and they can jump in and help. The other thing that they can do, if you turn on proactive engagement, they can tell you that there's a problem, because they can detect it sometimes before you can. And so we will talk on the next slides about how you turn that on. But enabling proactive engagement is highly recommended, so that they can help you, and they can often take steps to mitigate the issue before you even need to be involved. So it's more of a telling you that there's a problem rather than you experiencing the problem. Um, and so how do they help you? They do layer 7 analysis of logs. because they can see the logs. Now the logs are seeing is only metadata, so they're not seeing like the insides of packets, just the metadata of like the details about the headers and the IPs and stuff. But they can also set up geo blocking, as we were talking about. If they see all the attack traffic coming from Russia, they can just help you block the Russian traffic. So the point is, there's a variety of ways they can help. But the main takeaway is they're here to help. So reach out to them if you have Shield Advanced. And we recommend you have Shield Advanced to deal with DDoS. All right. The one of the last things I wanted to go over here real fast is the Shield Advanced setup. So you see, this is from the console, and number one, you have to subscribe, which should be kind of obvious. But then you have to turn on the protection for individual resources. So if an individual resource is not scoped in, it will not be protected. But the third thing is you have to enable SRT support if you want it, which means if you want the SRT to respond, they've got to be have the feature turned on in the GUI. And then the last piece that is not on this slide is a health check. You need a health check enabled so that the SRT knows that there's a problem. They will jump in automatically if they see an attack plus the health check is failing. So let's tie this all back to our scenarios. So in the first situation, you have only simple protection turned on, right? So obviously the next step is to get the proper protection turned on. So you need a rate limit rule. That's one aspect of proper setup, is to have a rate limit rule that we already talked about. Another aspect is to have health-based detection enabled, so that when your application is suffering, the SRT knows and the Shield Advanced tool itself knows. But what if you've got it set up correctly, but you're now under attack, and you're feeling the attack? In other words, there's business impact to the attack. The first step is call SRT now, because if you've got it set up properly, SRT will be able to jump in and help immediately. In the first case where you don't have it set up immediately, they may have a harder time helping you because they don't have access that they need. But if you set it properly, then they've got the access. Call SRT first, do that first, and then move on to the next step. And the next step is things like, is your health check accurately reflecting the status of your application? If it's not, then get it to where it does accurately reflect that status. And then, do you have proactive support enabled? Because if you do have it enabled, and the team, the SRT should be reaching out to you. You shouldn't have to be reaching out to them. So you shouldn't see an impact that they don't know about, is what I'm basically saying. And the last is, what part is being attacked. So if your logins are being attacked, there are managed rules within AWS that can help you deal with something like logins that are being overloaded. Is a specific part within your website being attacked, then you could do a rate-based rule that focuses on that one part of your application. So what's being attacked is critical to determining how to respond. And that is basically the whole of it. So I hope that everyone uh, got from this a way to mitigate DDoS using AWS services. And thank you for your time.